In this video lesson, you will be able to solve systems of linear equations. Today, the method that we are using is combination. Given two equations in a system, such as these, we have so far been able to find their solutions through using the methods of equality and substitution. Our new method is combination, and be aware that sometimes it is referred to as the method of addition or elimination. There are 6 essential steps in finding the solution to a system of two equations. In my two equations, 2x plus 3y equals 4 and 3y plus 5x equals -8, the first thing that I need to do is rearrange my terms if necessary so that my equation is put in ax plus by equals c form. In other words, standard form. My second equation is not written in that form, so I need to rearrange my x and my y terms so that it matches the equation above it. So my 5x and my 3y need to switch in the equation to make it now 2x plus 3y equals 4. And directly below that, I now have 5x plus 3y equals -8. My x terms are lined up, my y terms are lined up, and my c terms are lined up. Once my terms are lined up, I'm ready to move on to step number 2. In the second step, I'm going to multiply none, 1, or both of the equations by a constant so that the coefficients of one of the variables are opposite. I'm going to focus in on my y terms because this is going to be really easy to make 3y and 3y opposite of each other. Choosing either equation, and I'm just going to choose the second equation, I'm going to multiply through everything by -1 so that that positive 3y becomes -3y. When I do so, I'm going to distribute that -1 into the equation so that my new equation becomes -5x minus 3y equals 8. I'm going to go back up to my equation and replace it now that I have multiplied through by -1. Now that my y variable has a coefficient that's opposite, I'm ready to move on to step number 3. My third step is to add or combine the equations, which will eliminate one of my variables. And in this equation, my y variable is going to be eliminated. When I add my equations, I'm literally doing that. I am adding my equations. So 2x minus 5y leaves me with -3x. Positive 3y minus 3y leaves me at 0y, so I'm just going to cross that out. And 4 plus 8 leaves me with 12. Upon combining these two equations, I'm left with -3x equals 12, and this leads me to my fourth step. Solve. I'm going to solve for x in this equation. So dividing both sides by -3 leaves me with x equals -4. Knowing the value of one of my variables, I'm able to move on to my fifth of 6 steps. We're almost done. The fifth step is to use one equation and solve for the other variable. So I'm going to use the first equation in my system of two linear equations. I'm going to use 2x plus 3y equals 4. And I know that x equals -4. So what I'm going to do is plug in -4 for x. And now I'm going to solve for y. My y value is +4. My final step is to state the solution. So if x is -4 and y is +4, and my solution is the coordinate point where the two lines intersect, my solution is -4, 4. Let's now refer to our textbook to see how they walk us through solving systems by using combination. The book is walking us through the same 6 steps. It's just written out a little different. We used our equations with a bracket up and down. Here they have listed out the equation more horizontally. So instead of putting them in a bracket like this and then finding the combination of the variables, they've taken the 2 parts of the equation on the left side of the equal sign, set them to be combined on one side of the equal sign, while the C terms, the solutions on the right, are now on the right side of the equal sign. So they've gone through and been able to solve for x, which is 4.5, plugged that x value into the equation to find the y value of 1/2. Let's do a couple examples now, and you can choose to either do them more in the vertical way in the brackets, or you can choose to do them horizontally, like here on page 57 in your textbook. Our first example is the pair of equations 2x plus y equals 5 and negative 4x minus 2y equals negative 10. So to follow my 6 steps, my first step was to arrange the terms so that they lined up in standard form. My terms are already in standard form, ax plus by equals c, so I'm able to move on to my second step. My second step was to multiply none, one, or both of the equations by a constant so that the coefficients of the one variable are opposite. And you can choose to do any variables, but I'm looking here at my y. My y is in both of my equations. In my first equation, the coefficient is 1. And in the second equation, my coefficient is negative 2. So to go from 1 to negative 2, I want opposite. So I'm looking at negative 2 and I'm thinking, okay, I can multiply this by 2 so that my coefficient of y in the first equation is positive 2. That way my y variables are opposite of each other. So what I'm going to do is multiply this whole first equation through by positive 2. So my new first equation, or my equation, same value, just rewritten, would become 4x plus 2y equals 10. When I go on to solve this, continue on with step 3 and solve this system, I'm going to see a unique situation where that when I go through and I add my ax terms, my by terms, and my c terms, they're going to add to 0. So this is the unique situation in that there is no solution to this system of equations. So let's try a different one so that we can practice going through all 6 steps. First step. If necessary, rearrange the equations so that the terms line up as ax plus by equals c. My second equation is not written in standard form, so I need to rewrite it. You can see my work off to the side, how I've converted 6y equals x minus 7. Okay, the wild just won the game, so that's what you heard, my husband yelling in the background. And this now becomes negative x plus 6y equals negative 11 as it is put in standard form. So my new system I'm going to rewrite to look like this. My second step is to multiply none, one, or both of the equations by a constant so that the coefficients of one of the variables are opposite. I don't have to do that because my x values are already opposite, so I'm going to move on to step 3. I'm going to add my 2 equations together to eliminate my x variable. So x cancels out. 2y plus 6y becomes 8y. 5 minus 11 becomes negative 6. Dividing through by 8 leaves me with the y value of negative 2/3. So I've solved and I'm already on my 5th step. My 5th step is then to go back and choose one of the equations and then plug in this value of y into the equation to find my x variable. I've chosen my first equation and I've plugged in negative 2/3 for y. So I'm going to go on through and solve for the value of x. My value of x is 6 1/3. My final step is to state the solution and include values for both variables. So my solution to this system of equation would be 6 1/3, and negative 2/3. Follow these six steps and you will be successful to solving systems of equations by using the combination method. If you have questions, please let me know. But now it's time for our joke of the day. Why can't your nose be 12 inches long? It can't be 12 inches long because if it was, it would be a foot.
Made with Doodlecast Pro.